Assalamualaikum and good day. We are from grade 6 and today we will be presenting our data and findings for experimentary friction losses in pipe. By the end of this experiment or laboratory, students should be able to explain the fundamental or the mechanics of fluid friction phenomena in pipes. Also, students will be able to understand and apply basic knowledge of major losses in straight pipes. My name is Mohammed Arief bin Norzani, MA19153, and today I would like to explain or brief more on the introduction for the experiment. As we know, liquids or gas that passes through pipes or duct is occasionally used in heating and cooling application. These are the type of fluid that is used. So when the fluid is forced to flow through a system, it will experience some losses due to the frictional force that occurs inside the pipe. The continual loss of energy or total head of the fluid is actually the resultant from the frictional resistance in which it is subjected while it is flowing inside the straight pipe. The major loss in pipe is defined as the friction loss uniformly in straight section of pipe, in which caused by the viscosity. Determining the type of flow is usually based on the RE number. If the RE number is less than 2000, then the flow is laminar. But if the RE number is more than 4000, then the flow is known as turbulent flow. Next is about the objective of the experiment. Before presenting further regarding the objective of the experiment, we must identify the problem that occurs first during the experiment. So the main problem that occurs in the experiment is to find out the head loss due to the friction inside the pipe. Next is to investigate the head loss for experiment with elbow and bend pipe at 90 and 45 degree respectively. Lastly is to determine the relation with the fluid flow rate and also find out the type of flow that occurs inside the pipe. And the objective of the experiment is actually the opposite of the problem statement. So the first objective is determining the head loss due to the friction in the pipe, and also the head loss for every other setup. Next is to establish the relation with the fluid flow rate in pipe, and last but not least is determining the type of flows that occurs, whether it's laminar or it's turbulent flow. So before the experiment to be conducted, we must also first identify the scope of experiment. So here are the following scope of the experiment that has been identified. The material of pipe that should be used is PVC. Next, the length of pipe should be in 800 mm. Lastly, the use of PVC pipe with thickness of 1.5 mm with internal diameter of 20 mm. Thank you.
Assalamualaikum and good morning. My name is Mohammed SahrulFahmi bin Senan, and today I will present about the theory for the loss in the pipe. Okay, this is the basic equation for the loss in pipe, which is the Bernoulli equation. The fundamental approach to all piping system is to write the Bernoulli equation between the two non-point connected by a streamline. Okay, for example, in the case between the reservoirs and the surface and the pipe outlet. Okay, next. This is the equation for the friction loss. Friction loss are a complex feature of the structure of the system, the fluid properties, and the system flow rate. In the most engineering flows, the head loss is approximately proportional to the square of the flow rate. Okay, this is the friction loss, which is the Darcy-Weisbach equation. Okay, next I will explain about the Reynolds number. The Reynolds number is the fundamental dimensionless category, the product of velocity and the length scale divided by the kinematic viscosity. The term relative roughness refers to the relationship between the height of the typical roughness factor and the flow scale measured by the pipe diameter. Okay, next, this is the hydraulic diameter equation. Normally, for the non-circular pipes and ducts, we use this hydraulic diameter by substituting the diameter and treating the pipe as a if it were circular. So we use the hydraulic diameter equation. Okay, next, this is the friction factor. Since the head loss is proportional to the velocity rather than the velocity squared, the friction factor is inversely proportional to the velocity in the laminar flow. Okay, this is the formula for the circular pipe. F equal to 64 divided by the Reynolds number, and the non-circular pipe is the K divided by the Reynolds number. K we can get the value in the books. Okay, last but not least, this is the I will present about the minor losses. A thought there frequently equal for significant portion for the head loss, especially in the process piping. The additional loss caused by the entries and exit fitting and valve have historically been referred to as a minor losses. Okay, in the minor losses, we have a K value. Okay, factor that factors that affecting the value of K is the exact geometry of the component, the flow of the Reynolds number, the proximity to the other fitting. Okay, this is the figure 6 show the minor losses equation. And after we get the minor losses, we can adding the to the piping system with both pipe friction and the minor losses equation.
Hello, hi, Assalamualaikum. My name is Ngazima binti Salim. My matric number MA18204. So I will present about the method and procedure about the lab 3. So this is the safety precaution, which is protective clothing. You must wear the jackets all the times. Footwear, wear full covered shoes with strong grip. Electricity, sometimes the floor may be wet, so care is essential. Always switch off power before removing plug from the sockets. Instruction lab sheet. Any appropriate instruction sheet should be studied before starting the experiment or before enter the lab. Particular attention should be given to the recommended precautions, startup procedure and sequence of operation. Before turn on the switch, make sure all valve is fully closed. So next is experiment apparatus. The number 1 is fluid friction apparatus. Number 2, hydraulic bench. 3, pressure sensor. And 4, data measurement and data acquisition. So this is the experiment procedure. First of all, you need to open the all valve by turn left the tap, and then second, the pump was turned on by press the switch. Number 3, the volume of water was controlled by adjusting the control valve. So we need to know the flow of the water, and then we need to control it by using the adjusting control valve. And then number 4, the unused valve you must close by turn right the tap. And then number 5, the pressure was measured by install pressure sensor into the annular chamber. 2 pressure sensor must be installed. And number 6, the volume of water was adjusted by turn left or right the control valve. Number 7, the reading was recorded at the flow rate indicator and the unit is in LPM. The process was repeated for second experiment by changing the pressure sensor place. So first thing, for the first experiment, the pressure sensor placed at the top from the first line, and second experiment it will be placed at the last. So that's all from me. Thank you.
Hello, my name is Tanjung. number matrix MA18261. So now I will present the chapter 4, which is result in discussion on the rep 3, which is friction flow in pipes. So as you can see, there's a data of time for the experiment, and then we are given that the information of the experiment, which is length of pipe is equals to 800 millimeters, PVC pipe internal diameter is equal to 20 millimeters, and the PVC pipe thickness is equal to 1.5 millimeters. As you can see, the volumetric flows and the measured head loss are given for this four type of the pipe, which is straight pipes, elbow pipe 90 degrees, bend pipe 90 degrees, and 45 degrees pipes. So these are the equations we calculate for the experiment, which is the velocity, Reynolds numbers, coefficient of frictions, and the head loss. So velocity, we're using the formula which is a V equals to 4Q over pi d square, where the Q equals to the volumetric flow rate and the D is equals to diameters. Reynolds number is the formula using is which is Re equals to rho V D over mu. The rho is equals to 100 kg per meters cube, and the viscosity is equals to 8.9 times 10 power of negative 4 Pascal for the plastics, and the diameter we know is 0.02. So the coefficient of friction we're using a formula which is the 0.25 equals to rod strength over 2.7D minus 5.74 over Re power to 0.9, and the total load we use to power 2, and then we can get the coefficient of frictions, and the D is equal to 0.02 and the strength is equal to 0.0025 millimeters. The head loss is equal to F LV square over D2G, where the F is equal to coefficient of frictions and L is equal to length of pipe, which is 0.8 meters, V is velocity, D is diameter, and G is equals to 9.8 meter per second square. So this is a complete result of this experiment, which is the volumetric flow rate, measure head loss, velocity, Reynolds numbers, coefficient of frictions, and head loss for four types of the pipes. So we using the data given to plot the graph and then to see the difference between the measured head loss and the calculated head loss versus the volumetric flow. As you can see, that there's a huge difference between the measured head loss and calculated head loss for each type of pipe, which is a straight pipe, elbow pipes 90 degrees, bend pipe, and 45 degrees pipe. So now I will come to the discussion sections. So how the strain gauge can sense the pressure. Actually, the strain gauge sensor can measure the changes in length caused by the external force, which is the pressure, and then you can convert it to electrical signal, which can be converted to digital value and display and capture and analyze. So the spin part is like receives the magnetic loss from the process strength, which causes it to deform before return to its original state. Strain gauge can use to calculate these deformations, which can be analyzed use measurement electronics. So the second discussion, which is what would happen if the head loss if the diameter of pipe is decreased. If the diameter of the pipe decrease, head loss will increase. And what if the length pipe is decreased? So if the length of a pipe is decreased, then head loss will also be decreased. So what are the two type energy loss typically associated with the pipe fault? So the two type of energy loss associated in the field flow through the pipe work, which is the major loss and the minor loss. Major loss are caused by the frictional energy loss caused by the viscous effects of medium pipe wall roughness, while the minor loss is caused by the pipe fitting, change in flow path, and change in flow fields. So the most significant loss of the head incurred by the fluid flowing along the pipe, which is the major loss. The major loss we are associated with the frictional energy loss per length of pipe depends on the flow velocity, pipe length, pipe diameter, and friction, based on the roughness of pipe and whether flow is laminar or turbulent.
Assalamu alaikum warahmatullahi wabarakatuh. Today I'm going to explain about the result and discussion, which is about question 4 and 5 from the experimentary and friction loss. How can you find the values of minor loss coefficient from the experiment? Minor loss in pipes come from changes and components in a pipe system. This is different from major loss because those come from friction in pipes over long spans. If the pipe is long enough, the minor loss can usually be neglected as they are much smaller than the major loss. Minor loss in pipe flow play a significant role in estimating flow pressure and energy reduction in piping system because of the force acting on it, such as friction, gravity, liquid flowing through pipes has momentum and energy. In the same way as some elements of the system will maximize the fluid energy, and there are components of the system that work against the fluid, reducing its energy, velocity, or momentum friction. And small losses in the pipelines are significant contributors. The kinetic energy metric is used to quantify the conformation head loss, which is the energy loss to the system component. The conformational head loss can be calculated by using the equation of the head loss. And the second part, which about the critical Reynolds number with the theoretical value at which the transition from laminar to the turbulent flow occurs. Actually, here the most significant reason for the difference between the two are because all of the values of the Reynolds number, which are calculated from the data in the experiment, are greater than 3,500, which indicate that the flow is turbulent, and the critical Reynolds number calculated from the theoretical value at which the transition is laminar. This is all about the result and discussions. I will go to the conclusion part. In the conclusion part, which shows that the mean velocity of the fluid increase how? Throughout this experiment, the experimental values for the major and minor head loss are calculated and they are compared to the theoretical value respectively. Major head loss is caused by the frictional force in the straight pipe, and minor head loss is caused by the loss coefficient of the various pipe fittings. It shows that as the mean velocity of the fluid increased, the head loss increased. Moreover, the value of the mass flow increased. It's noticed that the value of the head loss increased as Reynolds number increased. This is due to the value of the Reynolds number, which is relying on the mean velocity of the flowing fluid. Here, the inconsistency of the result is caused by the some factors such as human and environmental factor. This is all from me. Thank you so much.